Alright guys, this is the Chapter 10 test review, the written portion at the back of the packet that I handed out in class. The first problem, number 16, what is the side length B in the triangle below? Of course that's a right triangle, so we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. The B value is not given, so the other leg we have to assume then is the A value, so the 8 that is given, and the longest side is the C value, so we plug 8 in for A, the B is still there, and we plug in 10 for C. So we have 8 squared plus B squared equals 10 squared. As we start to solve that, we're going to get 64 for 8 squared, then plus B squared equals 100, and then we are going to subtract the 64 from both sides. We get B squared equals 36, which of course results in B equals the square root of 36, which is 6. Okay, now on the next one, number 17, you have the square root of 128. Now we can use our multiplication property of radicals, which tells us that a single radical can also be rewritten as the product of two radicals, and vice versa. If you have two radicals multiplied together, they can form one radical. So we can take the square root of 128, we can break it into the square root of 64 times 2, then we separate those two radicals. We know that the square root of 64 is 8, so now we have an 8 on the outside of the radical, and we still have square root of 2, so we have 8 root 2. Number 18, we notice first of all that there's a subtraction sign in between, so those are radicals that are being subtracted, but they're not like radicals, so we can't simply subtract the 3 and the 4, and but we do ask ourselves what can be simplified, and you'll notice that the square root of 63 can be broken down into 9 times 7, so we rewrite that. 3 times the square root of 7 minus 4 times the square root of 9 times square root of 7, and the square root of 9 happens to be 3, so we can take the 3 out of the radical, we multiply that to the 4, and we get 3 root 7 minus 12 root 7. Now you have like radicals. 3 minus 12 equals negative 9, negative 9 root 7. Number 19, we notice, is two binomials being multiplied together. The first terms multiplied together, 2 times 2 gives you 4. The outer terms, 2 times negative root 3, give you negative 2 root 3. The inner terms, square root of 3 times 2, gives you 2 root 3. And then your last terms, root 3 times negative square root of 3, gives you negative square root of 9. So we simplify, 2 times 2 is 4. The middle terms cancel out because they are opposites, additive inverses, so that equals 0. And then the negative square root of 9 means minus 3. So we end up with 4 minus 3, which equals 1. On the last one, number 20, you notice that there is a radical. It's a radical equation. The radical is isolated, so we square both sides, and as a result we get the equation x squared equals x plus 30. Rearrange that, you get x squared minus x minus 30 equals 0. That is a quadratic trinomial. In order to solve that, we're going to factor it. So we factor that into x minus 6 times x plus 5. That equals 0. Using the zero product property, we set each factor equal to 0, and we solve them. And by solving, we get x equals positive 6 and x equals negative 5.